Remember that we've been talking about the rules of the exponents is that they're the inverses of each other. Okay, so basically, and we know that if we have ln e, then what does that equal?
1.
That is equal to 1. Okay, and we have a couple properties that if I have the log of a1, that is always, always, always going to equal 0. Okay, which makes sense because if I wrote that in exponential form, that would mean my base is a, my exponent is 0, and what's anything raised to the 0 power? 1. Okay, so any log 1 is always going to equal 0. Okay, anytime you have a log base a with the other a, or with an answer of a, okay, that's always going to equal 1. Because again, stop to think about it. If you write in exponential form, a to the first is going to equal a. Okay? So we can use some of these properties, and then we have a few other ones. So the first one, I'm going to jump down here, and then we'll go through all of these up there. Okay? So actually, you know what? I only want to do this one and this one first, and then we'll do those two. All right, so one of the properties says that if you're multiplying a log, that's the same thing as taking your m to the same exponent. All right, so if you think about it, if you have something with an exponent, you can just flip that down to the front and make it multiply. All right, so for example, if I had 3 log 5u, I could rewrite that as log to the 5th of u cubed. Okay? Or if I had log, let's say 5 to the v to the 4th, I can rewrite it so it's 4 log 5 to the v. Okay? It's a matter of just kind of manipulating and rewriting the same thing so that we can do stuff with it. All right, does that make sense? Okay, then, so let's take a look at what we have up here. I've got log base 2 of 2, but I have this exponent up here. If I rewrite it so that I have 40 log base 2 of 2, are you with me? Okay, well hey, what's log base 2 of 2 equal to? 1, so that means 40 times 1, and so my exact expression is 40. Good? Alright, I got another exponent. I'm going to throw that in front. Because, oops, what's the LNE equal? 1. So I can just rewrite it so that I can solve it easily without a calculator. Okay, good so far? All right, so one more time, I'm going to throw it to the front. Okay, so what is the log? My 7 raised to the log 7 is going to be the same thing as 1. And so I just get an answer of 2. Why did I say that 7 with the exponent of log 7 equals 1? Because if you think about it, 7 to the log of base 7, that's an exponent, right?
Yeah.
I can bring that down, and now I can say, oh, hey, log base 7 is 7, well, that equals my 1. Does that make sense? So it's basically I took the exponent down in front twice. Yes? Good. Alrighty then. Then let's do purple. Let's talk about some other ones. Okay. You know how multiplying and advertising, adding goes hand in hand? Well, that's true for your log rules, okay? So if you're adding 2 logs together that have the same base, you can write it as a single log. So my goal sometimes, I can not write today. It's like my words aren't flowing correctly out of the pen. It's crazy. So the goal is to write as a single log. Okay? Or separate them out. Either way. Okay? Today, our goal is to write as a single log. So, let's say I had log base 3 of x plus log base 3 of v. If I want to write it as a single log, since I'm adding, that means I can multiply the 2 because I have the same log base 3. You guys remember these? No?
I remember that.
Okay.
The first one we did, I can
Okay. Cool. That's why. All right. So just like adding and multiplying, if I subtract, what do you think I'm going to do? Divide. All right. So let's say we had log, let's just say x minus log base 3 of v. I can rewrite it as log base 3 of x divided by v. Key thing you want to do is that your first log is your numerator, and then the second log goes in your denominator. Does that make sense? So, top, bottom. Yes? All right, and then my last one just basically says that if you have your m and n equal to each other, then the logs are going to be equal to each other, which kind of makes sense. So let's say I have 2x is equal to 4. That means that the log of, let's let's say 3 of 2x is going to be equal to the log base 3 of 4. It's just kind of helpful if you have something like this, then you could say, oh, hey, well, 2x is 4. That means x is going to equal 2. Good? Okie dokie. Let's do a couple examples. All right. Since I want to find the exact value, I got to first step, write as a single log. So if I'm adding, that means I get to rewrite it. What, Mallory? Don't you put your head down.
I'm writing, right?
Look at her.
Right as.
Since I'm adding, what am I going to do? Rewrite it where I'm multiplying. All right, so log of 12 of 6 times 2. Okay, and then my second step is I'm going to either write as an exponent to solve or use properties to solve. Okay, what's the log of 12 of 12? Yeah, that's just going to equal 1 from the property. All right, Bibler, does that make sense?
Yeah.
Am I going too fast?
No, I'm just writing, so.
Okay. That could mean I'm going too fast if you're writing slow.
No, like I'm getting it. I'm just not writing all of it down fast.
Okay. All right, that's fine. All right. Since I'm subtracting, how can I rewrite it as a single? Using what? Division. So the log is 6 over 36 of 6, which is just going to be the log 6 of 6, which is going to equal 1. Alrighty. The next one. Let's rewrite it. I got 4 to the log of 4 of 3 halves. So I'm going to throw that down in front, my exponent in front. And so now I have 3 halves times 4 to the log base 4. But we said that if you have a number to the same log base, that is equal to 1. So I just get 3 half times 1 is equal to 3 halves. Easy peasy? No. All right. Main thing on this one is trying to get used to these properties and moving stuff around. Tomorrow we're going to undo it. So this, we're going to use the properties to rewrite that as a sum or difference. All right. So we're doing classwork, homework, evens, 13 through 28. Well, actually, that would be 14 through 28 since you're doing the evens. Duh. I'm the math teacher. What do I know? All right. Good. Alrighty then.